All right, quadratic roots. We spoke about quadratic roots today or yesterday, depending on when you're watching this video. Remember, quadratic roots are just the points where your quadratic equation crosses the x-axis. It'll be your zeros, okay? And we figured out the roots through our tables and through graphing, right? Today we're going to figure out the roots through factoring, okay? Through factoring, and that's what we're going to do today. So go ahead and write this down, and let's get started. So basically, you have all the steps here. Please pause the video and write this down. But basically what you want to do is you want to set your quadratic equation equal to 0 and then factor. And once you've factored, you want to set each factor equal to 0 and solve. And that's how you are going to get your solutions to a quadratic equation. Okay? And the reason why we're setting y equal to 0 is because we're looking for our x-intercept. So y is 0 when we have an x-intercept. All right? So in this example, if we want to solve this by factoring, we're going to set y equal to 0. So this is going to be 0 equals x squared plus 3x minus 10. And then we're just going to factor this. Okay? We're going to factor this trinomial. So we're looking for two numbers that multiply and give us negative 10 and add and give us 3. If you're still struggling with factoring trinomials, please watch the video please watch the video on that, factoring trinomials. So that would be 5 and 2, right? And because we want a positive 3, we want the 5 to be positive and the 2 to be negative. Now, here is where it's going to be a bit different. Okay, when we were factoring, we would just stop here. But now, we're looking for quadratic roots, so we're going to set each of these factors equal to 0. Right? So we're going to have x minus 2 equals 0 and x plus 5 equals 0. Right? And we solve both of these equations. So this one's going to be x equals 2. And this one's going to be x equals negative 5. And there you have it. Those are going to be your two solutions. Those are going to be the 2 points where your I can't even speak right now, where your quadratic equation is going to cross the x-axis. It would be at negative 5, 2, or negative 5, 0, and 2, 0. Those would be your two ordered pairs where your quadratic equation, or where this particular quadratic equation is going to cross the x-axis. Let's do another example. So again, it's already set to 0, so that is useful, that's helpful. So what you're going to do is you're going to factor this. So now you're going to look for two numbers that multiply and give you 3, add and give you 4, which is going to be 3 and 1. 3 times 1 is 3, and 3 plus 1 is 4. And then you're going to set each of these factors equal to 0. So it's going to be x plus 3 equals 0 and x plus 1 equals 0. And if you solve these, you get x equals negative 3 and x equals negative 1. So your two solutions are going to be negative 3 comma negative 1. Those will be your two solutions, and that's how you would find the solutions of a quadratic equation by factoring. Let's do a few more examples. So here we have negative 27. So that means we're going to be, when we factor this, we're going to be dealing with a positive and a negative. All right? And then you think of two numbers that multiply and give you 27, add and give you 6. Well, that's going to be 9 and 3, right? Now, which one's going to be positive? The 9 is going to be positive, and the 3 is going to be negative because we want a positive 6. All right? And then we factor. Then we set each factor equal to 0. So there's going to be x plus 9 equals 0 and x minus 3 equals 0. Solve both of these and we get x equals negative 9, and over here we get x equals positive 3. So your two solutions are going to be negative 9 and positive 3. That's it. Another example. We have a positive 21 and a negative 10. So when we're factoring this, that tells us that we're going to be dealing with two negatives. Two negatives would multiply and give us a positive, and two negatives would add and give us a negative, right? So this would be 7 and 3, it looks like. 7 times 3 is negative 7 times negative 3 would give you positive 21, and negative 7 plus negative 3 would give you negative 10. Set them equal to 0, and then set each factor equal to 0. So this is going to be x minus 7 equals 0 and x minus 3 equals 0. So that'll be x equals 7 and x equals positive 3. So your answers, your solutions are going to be 3, 7. All right, now this is not a trinomial. So how would you factor this? Well, looks like we have greatest common factors here. It looks like we have a 3. A 3 is the greatest common factor of 3 and 15. So we could actually factor out a 3. And it looks like we could also factor out, or we could also take out 1x because both terms have an x. So this is factoring by greatest common factor. So review those notes or those videos if you forgot how to do that. If we take a 3x out, all we're left with is x plus 5 equals 0. So now you are going to go ahead and set both of these factors equal to 0. So one of them is going to be 3x equals 0, and the other one is going to be x plus 5 equals 0. Well, that's just going to give us 0 over here, and that's going to give us x equals negative 5. So your solutions are going to be negative 5, 0. All right, so here we have x squared minus 25. So this is the difference of squares. Remember, when we have a difference of squares, a squared minus b squared equals a plus b times a minus b. So you take the square root of x squared, that's x. Take the square root of 25, that's 5. So it's be x plus 5, x minus 5. That equals 0. You set both of your factors equal to 0. So that's going to be x plus 5 equals 0 and x minus 5 equals 0. So it would be x equals negative 5 and x equals positive 5. Those would be your two solutions. Negative 5, positive 5. Now, what about if the equation is not in standard form? What would you need to do? You would need to move it. You would need to change it to standard form. So move, then factor, then solve. All right. So here we have a 21. We don't want a 21 here. So the way what you would do here is you would subtract 21 on both sides and get that to be a 0. So subtract 21 on both sides, and that would just give us x squared plus 4x minus 21 equals, and then that right-hand side would give you that 0. Now you could go ahead and factor this trinomial. So we're looking for two numbers that multiply and give us 21, and that would add and give us 4. And it's going to be a positive and a negative. So that's going to be a positive 7 and a negative 3, right? Positive 7, negative 3 would give you negative 21, and positive 7 minus 3 would give you positive 4. Then you would set each of these factors equal to 0, which I forgot to bring down. I'm sorry, equal to 0. So that's going to be x plus 7 equals 0 and x minus 3 equals 0. Which when you solve these two equations, you get negative 7 and positive 3. And those would be your two solutions. Negative 7, positive 3. And let's do one more. So again, we're going to want to move before we could factor. So subtract 4x on both sides. And that would give you x squared minus 4x minus 45 equals 0, because we don't have an x over here, so we can't subtract it by anything. So we just bring it down here. So now we can go ahead and factor this trinomial. So we're looking for two numbers that give us a negative 45 when we would multiply them, which would mean that we were dealing with a positive and a negative. All right, and 9 times 5 is 45. 9 minus 5 happens to be 4. Now because we want a negative 4, we want the 9 to be negative and the 5 to be positive. Then you set each factor equal to 0, so that would be x plus 5 equals 0 and x minus 9 equals 0. And if you solve both of these equations, you get x equals 5 and x equals positive 9. So, I'm sorry, that should be x equals negative 5 and x equals positive 9. So your two answers are going to be negative 5, positive 9. Those would be your two solutions to this particular quadratic equation. Those would be your two roots. All right, that's it. Make sure you have all these notes done. I'm going to check them tomorrow. Have a great day. I will see you tomorrow.